All right. Well, good morning and good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. For those, if it's your first time to Exploring by the Seat of Your Pants, we are all about bringing science, adventure, exploration, and conservation live into classrooms across North America and beyond. So if you head over to exploringbytheseat.com, you can find 30, 40, even 50 live events a month for classrooms to join into. Register, tune in live on YouTube, or join in a camera spot to interact and join the fun. All right, October's been a pretty awesome month. We have been celebrating space exploration. We have been talking to scientists, we've been talking to explorers, astronauts, engineers, everybody working in front of the camera and behind the scenes to make space exploration possible. So it's been a ton of fun, and we're rolling along today with another exciting event. I do want to give a shout out. I can see tons of classrooms starting to tune in live via YouTube and Facebook. We're going to use that comment space for introductions, of course, but then we also want questions. Lots of questions coming in via that chat for our guest today. Speaking of our guest, let's get right to it. So recently named one of Time magazine's most influential people of 2020, Jessica Meir returned to a very different planet after 205 days aboard the International Space Station. During her first space flight, she conducted the first 3 all-women spacewalks with crewmate Christina Cook of NASA, totaling 21 hours and 44 minutes. The crew contributed to hundreds of experiments in biology, earth science, human research, physical sciences, and technology development. Previous to her space flight, Jessica obtained a doctorate in marine biology from Scripps Institution of Oceanography and was an Aquanaut crew member living and working in the Aquarius underwater habitat for the 4th NASA Extreme Environment Mission Operations, or NEEMO mission. So I'm going to bring Jessica in live with us now. Here we go. Jessica, how are you doing today?
Hello, everybody. I'm doing well. How are you?
Good, good. Well, Jessica, it's so great to have you joining us live today. We've got classrooms on camera across the United States and Canada. We've got even more classrooms joining us live via YouTube and Facebook. And we're really excited to get to know you a little bit better, talk a little bit about your space flight. And then, of course, they're just going to bombard you with questions. So I think it's going to be fun.
Looking forward to it. Hello to all the classrooms.
All right. Well, Jessica, I'm going to let you take over for a little bit, and then I'll come back in shortly.
Okay, well, why don't you go ahead and roll the video? I think this will be a great introduction. We'll show you some highlights of the mission, and I'll give a little bit of narration as well. So here's a view of the Soyuz rocket being rolled out, and this is the Russian spacecraft and rocket that I launched in from Kazakhstan. Here we are in our spacesuits getting ready to go on the rocket, and that's my Russian commander, Oleg Skripochka, and then also the very first astronaut from the United Arab Emirates, Haza Ali Al-Mansouri. So pretty exciting historic moment for them. Here's the launch of our spacecraft, and here we are leaving Earth and heading toward the International Space Station. Here's a picture actually from a camera on the outside of the rocket that shows the separation of the stages. And this picture was taken by Christina Cook from inside the space station. You could see our Soyuz spacecraft actually headed toward them. And this is our view looking at the docking port of the International Space Station. As you can see by the look on my face, pretty incredible moment. I don't think I've ever looked happier, and luckily that smile stayed for pretty much the whole 7 months. Pretty extraordinary feeling. A diverse crew. There were 9 of us up there for that first 8 days. Then we went down to this crew of 6. And then eventually for the last 2.5 months, there were just 3 of us on board. So really interesting to experience a space station with all those different numbers of people. One of the best things about being in space is just simply floating. It makes everything so much more fun. Even creating space charcuterie boards. Sometimes you want something other than the rehydratable food, but this is how we standard preparation of our food with the water dispenser. Even mealtime is a lot more fun in space when you can throw food at your friends and play with water bubbles. Exercise is incredibly important on the space station. We have 2.5 hours allotted in our day to lift weights and then also to bike or run. So we really need that loading to keep our bones and muscles healthy. Incredibly important part of the mission. And then the treadmill and the bicycle ergometer give us that cardiovascular conditioning as well. washing your hair, daily hygiene in space. Everything's more fun in space. Even holidays, we had some costumes to pay tribute to the Apollo 12 mission and the Apollo program in general, since it was the 50th anniversary last year. And you can hear us, if you give a little bit of the volume there, Joe, you can hear our crew playing and serenading the ground with our band rendition. We have instruments up there, a guitar, keyboard, my piccolo. But of course, science is really the most important part of what we're doing up there. So here are some views of those operations. This is combustion science, so even flames burn differently in space. We do lots of different experiments looking at physiology and medical effects of spaceflight. This is us loading the airlock in the Japanese segment. We're actually putting a small satellite on there that will then launch from an external platform. Here it comes, and now we've launched a small satellite in orbit. We grew lettuce in space, so looking at differences in different wavelengths of light, and that'll be really important to the sustainable food sources for long-duration space missions. We have this glove box where we can do lots of different cell biology, tissue culture type experiments. We do a lot of physiological studies. Here we're using ultrasound to image Drew's blood vessels, looking at the differences in blood fluid dynamics and the shift in space and also the effect on the eye. And that's our freezer, just like a -80 freezer in the lab where we can keep our samples and different materials that need to remain frozen. Spacewalks, we were very active with spacewalks. We actually did 9 spacewalks in a 4-month period, which is really kind of unheard of. Usually there's only maybe 1 or 2 spacewalks in that kind of time frame. We had our hands full doing 9 of them, but we loved it. Spacewalks are really the most rewarding part of the job. And here, Christina Cook and I are coming out for that first all-female spacewalk in October of last year. Really incredible feeling to come out of the hatch and see nothing separating, nothing between your boots and the earth below. Pretty phenomenal views from there, as you can imagine. There, that was me, and this is Christina. We were doing some work for the power channels. We were upgrading batteries for the International Space Station using new lithium-ion batteries in place of the older ones. Another thing that we do, we have lots of visiting vehicle traffic. So we have lots of spacecraft coming up to visit, not with people, but with lots of cargo, hardware, experiments on board. And we use the Canadarm, the robotic arm from the Canadian Space Agency. We fly that over and grab the visiting vehicle and bring it over to dock to the space station so that we can unload all the different cargo. So that's the HTV, a Japanese cargo vehicle. We also have the SpaceX, and we have the Cygnus cargo vehicles that are launched from the US. There's a picture of the SpaceX. The SpaceX is actually the only one that then returns to Earth. So it splashes down in the ocean. We can send different pieces of hardware or scientific samples down to the Earth. The other vehicles are actually filled with our trash, and they burn up in the atmosphere. Earth observations photos are incredibly important for a pastime, for our own enjoyment, of course, but also for science. We're able to document things like the retreat of glaciers over time using the same vantage point of the space station. We have a record now that goes back decades, and that helps glaciologists and climate change experts look at the retreat of those glaciers. And it's just always a phenomenal view. It never gets old to look out the window at that extraordinary Earth below. And the view is always a little bit different, depending on your position, depending on the lighting, depending on the weather below. It's really extraordinary and really does shift your perspective. There's a sunset view, and coming up, you'll see some nighttime views. Those flashes are lightning, and the rest of the lights are city lights across Europe and into Asia. That's the Nile. So all those lights are the civilization along the Nile River, and the big spot on the top, that was Cairo and Israel off to the right. And now you can see the aurora. The northern and southern lights are so incredible to see from space. It's this otherworldly glow dancing in front of you. Sadly, after 205 days, we had to go home. And even at that point, I would have much rather stayed up there longer. I was having such a great time up there and we were being so productive. I was very sad to say goodbye. And as Joe mentioned, also to know that I was coming back to this very, very different planet than the one that we left. Here we are in the Soyuz spacecraft, and now we've undocked from the space station, getting ready to do our little deorbit burn and re-enter the atmosphere. A view from mission control. Of course, they're monitoring everything. And here we come through the atmosphere. You can see that drag from the density of the atmosphere is actually burning up. We're actually flames you can see through that window. And then we're touching down there in the middle of Kazakhstan. Within 24 hours, the NASA jet brings us back home to Houston. We're able to hug a couple people that had been in quarantine for us, but otherwise we were in quarantine for about a week, given the COVID situation on the ground, to make sure that we didn't contract anything, because we actually have compromised immune systems when we come back from space. So that wraps up the video. And I thought now, before we move on to questions, I would show you a little bit about what I've been doing since I've been back on Earth and combine that with some of the views that we had from space. One of the things that really helped me adapt to being back on this planet, and I was missing being in space and floating so much, but I love nature and I love exploring, just like I'm sure all of you do, and all of the different explorers and scientists that you've had on this program before have in common. So I'll show you a few examples of my immersion into nature to really kind of have what we call nature therapy in my family. So the first thing that I did, I left Houston and I headed north in my car and I drove up toward my sister's in Boulder, Colorado. So here's a view of this area that I took obviously during the winter, given the snow. I took this photo last winter when I was still in space, and you can see the Rockies in the top left, and you can see the area around Boulder there. I went for some great hiking and camping trips with my sister, pictured here in the Rockies, and we had some beautiful views, beautiful flowers, all of the wildflowers popping up. And I spent a lot of time in Colorado skiing, but I hadn't really been there in the summer to see all of this. So we had some beautiful views and wonderful hikes in the Rockies. Later on, I was actually in Southern California, and here's a view of that area from space. You can see the Baja Peninsula on the bottom, the Salton Sea, and then up toward the left, up the coast, you can see San Diego and Los Angeles. And I spent some time around the beaches. My brother lives in Malibu, so I visited with him and was out in the ocean and on the beaches, and even had the opportunity to get some pretty cool photos taken there by a professional photographer, my friend Magda Wazinska. And there's a picture of that time in Southern California, but lots of time in nature there too, hiking in the canyons and surfing and swimming and stand-up paddleboarding. So really nice to just be back on Earth, given all the extraordinary views I've had. And then I actually road tripped from Southern California through one of my favorite spots to see when I was in space. And this is a Navajo Nation area around north and east of the Grand Canyon, around Lake Powell and the borders of Arizona, New Mexico, and Utah. And this area is just so striking because you see the fantastic color palette. There's all these reds and these brilliant colors and the river snaking through, and it almost looks like a different planet, just these wonderful colors. And I remember the first time I flew over and how extraordinary it looked. And I was thinking, man, I really need to go there and see it from the ground. So I did. I went there on the road trip, and we went to Moab and did some hiking and some camping there, and seeing that red color this time from the ground, how brilliant it is, and really everywhere. It was such a cool perspective to have seen that from space, and then now to be appreciating it from the ground. So again, just this kind of the spirit of exploration. And I know I was so lucky to have the vantage point I did from space, but then I wanted to feel it and explore it from the Earth as well. So with that, I think we can move on to field some questions, Joe.
Absolutely. Jessica, thank you so much for sharing your time in space with us, sharing your perspectives when you got back home and visited some of those places. Maybe this will be hard for you to answer, but did you have a preference to when you were kind of going over top at a high rate of speed, or was it better to be immersed in the environment, or do they both have their pluses?
I think they both have their pluses, but I would say I think overall, just the excitement and how different and special it is to be in space. I don't think I've ever been happier. But it's kind of ironic in a way too, because you have this incredible vantage point, the most beautiful views of the entire planet, but you can't actually enjoy any of those ecosystems. You can't feel the breeze on your face. You can't smell that fresh mountain air or that forest, the trees. So it is a little bit ironic that you have the best views, but you don't get that pleasure of all of the other senses. So I think I really like the combination. I'd love to be back in space again, but meanwhile, I'll enjoy all of it on Earth.
All right, fair enough. Well, there's a common theme that we have here on Exploring by the Seat of Your Pants. We talk to scientists, explorers, adventurers, conservationists, and, they have all found a way to turn their passions into a career so that their job, doesn't feel like work. Can you tell us a little bit about how, you were able to do that, take your passions and channel them into a career?
Absolutely. And that's always the kind of advice that I give too. You really need to identify your passion and make sure that that's what you're pursuing, because I just don't think that you'll be able to really excel or do wonderful things in a field if it's not something that you truly care about, something that truly drives you and inspires you. And I think more importantly, that you won't really be happy doing it. So if you can find a way to combine that passion and that excitement with actually a profession and earn some money doing it, I mean, I say that all the time. I can't believe I get paid to do this. It's extraordinary. Even with our training on the ground, that's true. But I think that's the utmost of importance is to do that, to find that passion and embrace it, because the opportunities are there when you set your mind to it. You find and identify that thing, and then you do have to put a lot of hard work in, of course. You need to be willing to take those risks and push yourself, sometimes even outside of your comfort zone. That's when the great rewards really come. And you need to realize that you can, and you should fail along the way, because that's when we learn the best lessons. And of course, I failed along the way as well. We all did. And that's the only reason why we learned the right lessons to end up where we are today.
All right, absolutely. Well, I think you're right. I think it's time to meet some of our classrooms. Those who are tuning in via YouTube, use that chat sidebar, shoot some introductions my way. We'll give a few shout outs. And then let's start meeting some camera classrooms. So we're going to go to North Bay, Ontario first. We have Miss Saunders, grade 6s, hanging out with us. How are we doing, grade 6s?
Way good.
All right,
Hey,
we're ready for you.
Okay. Hi, my name is Ryan, and I was wondering, when COVID started, was there a difference in the use of light energy from your perspective in space?
That's a great question. People ask that a lot. Could we actually see the differences? Everybody's lives had changed so dramatically down on Earth. And I think it's a little bit difficult from our vantage point on the space station, because we're not always flying over the same spot every day, and the lighting changes and our position changes slightly. So you'd really have to do, I think, some kind of systematic study to document the before and after, and then really analyze it. One of the things that we could definitely see was the lack of aircrafts in the air. So, we can see the contrails in busy aircraft areas on Earth. There was definitely a difference there since air travel had been decreased so significantly. And I think, if we tried to look systematically at the different light patterns, I bet we would have seen a shift from kind of downtown areas where there's a lot of business and commerce, which maybe those downtown areas would have been a little bit dimmer, and maybe some of the rural areas where more people live would have been a little bit brighter, since people were really staying at home. I don't have the data to back that up, but I bet we could come up with some satellite imagery or something if you want to try to test that hypothesis.
All right, great question to get us started. We're going to head a little further south. We're going to go to Tuscaloosa, Alabama this time. We've got some grade 7 and 8s hanging out with Mrs. Foster. Let's bring them in live. Hey, Alabama.
Hey. What was going through your mind as you were going into space?
A lot of things. And it's really interesting because we're very busy actually on the spacecraft. I was in the left seat, so I was essentially the co-pilot, helping monitor all the systems and make sure that everything was going according to the schedule and properly, and monitoring that with my commander. So I was very busy and focused on the screen in front of me, going through the different checklist procedures that we have. And interestingly, it actually felt just like all of the simulations. We spend so much time on the ground. A year and a half of that time, most of that year and a half before the mission, I was in Russia training with the crew, training in these high fidelity simulators where everything looks exactly like the real vehicle. So I'd gone through all of those things, that whole protocol and all those procedures so many times before that I actually had to remind myself that it was really happening, that this time it was on a real rocket and we were going to end up in space instead of just leaving the simulator and going home at the end of the day. So for me, it almost didn't feel any different at first. And I had to remind myself. And then occasionally I would feel a small sway in the rocket, or you would kind of hear the engines, or you would hear some machinery, and you knew, wow, this is going to be different. We're actually going at this time. And then after those engines light and you can feel the intensity of the thrust and the acceleration, and then you can start seeing things out your window as the different stages of the spacecraft separate and you get higher and higher. And then suddenly you're in space. And this is only just over 8 minutes after we've taken off. And at that moment, you're still strapped into your seat. So, your whole body doesn't float up or anything, but you can feel everything kind of lifting up. And you see all of the dust or any little particles of anything that's settled down to the floor of the spacecraft with gravity. Everything kind of lifts up, and your pencil in front of you, and you can see it all. And that moment just felt so extraordinary. And you can feel, you kind of have this sense that you're hanging off the monkey bars in the playground. When the blood rushes to your head, it's kind of filled up and congested because now gravity isn't pulling the blood down to our feet. We kind of have this shift and your face gets kind of full and you can feel that sensation. I felt like I was a bat hanging upside down all the time. And then that feeling just persists. It doesn't go away. But after a little bit of time in space, your body kind of compensates and adapts and gets used to that feeling. So incredible excitement. I was never happier than that moment when I realized I was in space, looking out the window and seeing the curvature of the Earth, and then joining all of my friends and colleagues on the space station.
Oh, absolutely amazing, Jessica. I can only imagine what it feels like, the whole process, and that force as you're pushed out of the gravity and out of the atmosphere must have been just incredible. I want to give a few shout outs to some YouTube classrooms because we have so many classrooms joining us. I want to give a few shout outs to classrooms. We've got classrooms joining us in Alaska and California and Florida, New York and New Jersey, Wisconsin, Tennessee. Then up here in Canada, we've got some classrooms in Alberta and British Columbia and Ontario. So thank you to everybody who's joining in live today. And let's get one of these YouTube questions coming Jessica's way. So Ms. Salzberg would like to know, kind of building on what you just told us about your first experience in space, could you feel other effects over time on your body, or most of the effects did you feel when you kind of came back to gravity?
Yeah, that's a great question. So I think most of the extremes that you really can sense yourself, you do feel in the beginning as your body's adjusting. So kind of those moments that I was just describing where you feel that kind of pressure and congestion in your head, and that lasts for a little bit until your body adapts. But then it was really interesting. After a few weeks, I felt totally comfortable in microgravity. Floating around felt normal. And it was funny. We would have these conversations up there and think, man, won't it be weird to walk around and have to put shoes on? And that suddenly seemed foreign to us because we just became so accustomed to all of this floating around. So after that initial sort of acclimation period, I think things do really seem quite normal. And then the biggest change is coming home. I would say coming home is much more difficult, much more uncomfortable than going to space. And I find that very interesting as a biologist, because if you think about it, for the entire human species, the entire civilization, throughout the entire period of evolution, we've always had this 1g, this gravitational vector on us. So you'd think that it should always just feel more normal to be back on Earth than it would to be elsewhere. But if you think about the direction of the forces and what's happening with gravity, perhaps that does make more sense, that it might be easier to go up than it would be to come down and suddenly feel that pressure again. And so I think that's why, you know, at least for me, it was harder to come back, not only mentally, since I still wanted to be in space, but really physically. When you come back, you can literally feel gravity, which sounds strange, but imagine, you know, now your body is adapted to life for months and months without it. So it feels as if somebody's pushing you down into your chair, you know, kind of like if you have an older sibling or a bully on the playground that's putting their hand on your head and pushing you down and kind of feeling that weight. You can just simply feel gravity, and it makes you quite tired when your body is getting used to it again. You feel pretty exhausted. You sleep quite a bit in the beginning. Even remembering how to run again is a bit odd. Walking comes back pretty quickly, but then since running is more of a complex motor neuron, you know, you have inputs from your brain going to the muscles. That actually felt pretty strange. The first time I tried to run, after a couple days, I would feel normal coming up, but then on that kind of that downstroke, when your foot makes contact with the ground again, I felt like an elephant. I felt like I was falling, and there was a tremendous weight on me just in terms of how my brain and body was interpreting all of that. So it's a really interesting process, but your body then, of course, does get used to it again. And after a few weeks, you feel pretty normal walking around. And then, you know, some people have some lingering back pains or some other issues. But I would say at this point, you know, after a couple months, I felt really pretty normal, and I feel completely back to normal now.
All right. Were you a little bit taller when you got back?
So there is an increase in height in some people while they're in space, and that's just because without gravity, your discs in your back actually spread out a little bit more. They're not as compressed, and your spine can straighten up a little bit. So I don't think I actually grew very much, maybe a tiny bit, just based on how my spine was shaped before I went. But unfortunately, as soon as you return back to Earth and have gravity again, you kind of lose that height advantage you might have had in space.
All right, fair enough. Let's visit another live classroom here. We are going to go to Mr. Fisher's class this time. Let's bring them in. They are joining us from Canada, Ontario. So it looks like some grade 9 students. How are we doing, everyone?
All right, so my question is, what type of process did you use to grow the lettuce? And did you reuse your waste to help and grow and fertilize those plants?
Yeah, great question. That was a really interesting experiment that we did. And the goals of that experiment, it was called the Veggie 4. There had been some other veggie experiments before. And we were growing Mizuna lettuce in 2 different conditions. So looking at a more red wavelength of light and a more blue wavelength of light to see which helped the plants grow better. And we were also evaluating a different fertilizer. And that fertilizer was actually not based on any of our waste. It was all contained within a little root mat to make it easy and to make it optimal for the environment on the space station, so things aren't floating away. So everything was contained, and all we had to do was water the plants through a small tube, and we would attach a syringe and water the plants, at every few days whenever they needed water. So that was our main interaction, and then harvesting the plants at the end. And that was a great moment because we, of course, had to send about half of the samples down to the ground so they could be analyzed, but then we got to eat the other half. And it was great to have a fresh salad up there. I eat salad almost every day on the ground. So it was really nice to have some fresh vegetables instead of just the rehydrated stuff that we normally have. But I really liked your question about, did we reuse our waste? Because that's really the way that we need to be thinking about making space travel more sustainable for the future. Right now, we don't use our solid waste on the space station. We may or may not have a need or have a use for that in the future. I hope we do. I think we'll get there to be even more regenerative. But what we do use is we do collect all of the liquid waste. So all of our urine, and also all of our sweat, any moisture in the air is collected through the air conditioning system, essentially. And all of that is actually filtered and recycled and then used for drinking water. So we are able to reclaim 80 to 90% of all of the water that we use on the space station. So really impressive and a great example of how sustainable we really can be if we have the right technology on board. So as we say on the space station, yesterday's and today's coffee will be tomorrow's coffee.
Okay, and I think that's a really cool point. Is a lot of technology that we're using down here now, some of it was first developed on the space station. So I think that's really neat too. It's a real great testing ground, and some of that technology makes it down here for us to use in our everyday life.
Right, and you can see in the background photo there, that's the solar array. So really another great example of how we're using all solar power, all renewable energy on board to fuel the space station, and then recycling it, kind of mimicking what we do here on Earth with the atmosphere and how the whole water cycle and how things get reabsorbed and added back to the water cycle system. So a great example of that in space.
All right. Let's take a little trip now to Cumberland, Maine. We've got Miss McGinnis's fourth graders joining us. I'm going to bring them into the call. Hey, fourth graders.
Everybody.
All right. Hello to my home state of Maine. Hope you guys are doing well.
My name.
Hello, my name is Cohen, and what's the most fun thing you did in space?
There were so many fun things. All the scientific experiments, the spacewalks were probably my favorite part, but I would answer the question by just saying simply floating. Like I mentioned, the fact that you're floating all the time, it makes everybody just kind of happier. You have this sense of levity. It kind of brings you back to your 5-year-old self when you just want to play and float around. And so even if you've just finished doing a scientific experiment or a hardware repair, or you just finished eating lunch, sometimes you might find yourself just bouncing up and down or turning into a somersault, doing a somersault, crunching up in a ball. And you do that stuff just because you can. Everything in space is just so much more fun when you can float.
All right, let's grab a couple more questions from YouTube. We've got Mrs. Shelton's class. They're joining us in California, and they're wondering a bit more about the logistics of the spacewalk. So was there a time that you lost anything? And if not, how do you keep everything, close and not drifting away?
Excellent question. We did not lose anything on our space flights, and I was on our spacewalks. I'm very happy to report. It does happen sometimes, sometimes these things happen, but what we do to prevent that is we have everything tethered to us. So all of our tools, all of the hardware that we're going to use, we have these small tethers that we attach first before we release it, or we just take a tool off of our little workstation and it already has a tether on it. We can use the tool, and then if we were to drop it inadvertently, it would just still stay attached to us with this tether so that we wouldn't lose it. Because if you didn't use those tethers, if you let go of something or you dropped it, it would float away from you and you could very easily lose something. We want to avoid that because, of course, all of our hardware and equipment is very, very expensive. We also don't want to cause any damage to the space station if then that tool were to hit something on the space station or could hit some kind of other spacecraft or satellite in orbit. So we do everything we can to avoid it, but luckily we did not lose anything during my spacewalks.
All right, we've got another student. We've got a class in New Mexico joining us, a 10th grade class, and they're studying animal and human microbiomes right now. So the bacteria, living inside of us and on us. So they're wondering, were there any other kind of tests or experiments you did on the space station other than maybe collecting your own, samples, waste samples?
Yes, all kinds of experiments ranging from our own samples to cellular biology, looking at different types of cells like bone cells, like muscle cells. But in terms of sampling the microbiome, we are doing that as well and sampling the biome of the space station itself. And the main reason why we do that is to make sure that it's safe and doesn't have anything growing on it, any kind of substance that might harm us or be deleterious for our health. So we routinely actually take samples of the water, of the air, and of the surfaces as well. So we have these cell culture samples that we'll be able to, some directly look at and process, but most of which we send back to the ground so that they can analyze them. And then we can take any other precautions if we need to clean something or we need to change something with the water supply. So great question. That is something that we do routinely monitor.
Okay, let's jump to another live classroom now. We're going to go another group in Alabama. This time they're in Newmarket. They're a 5th grade class with Mrs. Moore. Let's see if we can bring them in live here. There we go. Hey, Newmarket.
Hi. I'm Tristan, and my question is, does everything float in space?
Yeah, well, what do you think?
I don't know.
Yeah, you're right. It does. Everything floats. So I'm floating. Everything within the space station is floating. And that's because everything is really falling back to Earth at the same rate. We are still being pulled back to the surface of the Earth because of the Earth's gravity, but we're moving at we're high enough up that we don't actually come crashing back into the atmosphere. We maintain this orbit. So basically what that means is everything, all of the objects, no matter how large or small they are, they're all susceptible to those same forces. So if I'm sitting here with my food in front of me or a piece of hardware in front of me, everything is experiencing that same relative effect. And so everything is floating in exactly the same way. So I'm floating inside the space station. If I go outside of the space station in my spacesuit, I'm still floating, but I don't really have a sense of motion relative to the space station because it is subjected to the same forces that I am.
All right, I'm going to bring in another live camera classroom here. We are going to go to London, Ontario, sixth graders with Ms. Bahala. How are we doing, sixth graders?
Hi.
So I have a question. What was your favorite experience in NASA?
My favorite experience at NASA was definitely going to space, but there are a lot of other really cool things that we're very lucky to do. And so sometimes our training can be almost as exciting as being in space. And I would say there are two that come to mind. One was a job that I had in my first few years here where I was the person in the Mission Control Center that was guiding the astronauts through a spacewalk that was happening on the International Space Station. So I was on the ground, but I was really an expert in the specific procedure that they were doing. So it was my voice that was talking to them throughout that whole spacewalk. And that was a really educational opportunity for me. I learned so much about the spacewalk process, and it was really cool to be contributing to that. The second thing that I did that was such an incredible experience was living in a cave in Sardinia in Italy. We have something called the Caves Analog. It's run by the European Space Agency, and it's used for astronaut training because if we want to try to recreate elements of space, it's difficult to do that. We can't just do that on Earth. So we try to find environments that have some things in common. Maybe they're inhospitable. Maybe you need a life support system, like you need a scuba tank because you're living underwater. You're living in a small confined area with a small number of people. A lot of similarities between how we conduct things in space. So I got to be a crew member on this caving mission, and it was incredible. This was a highly technical caving mission where we went into this cave. It was 25 kilometers of branches all underground and through this one hole. 1 minute you would be crawling through a tiny, tiny little hole that you don't even think your head will fit through. And then suddenly you come out into this enormous gallery with 100-meter wall in front of you. And these beautiful, beautiful structures, some of which look like they were carved by artists in marble. And it was just such a cool experience. It was like really exploring. We were mapping the cave. We were doing different types of scientific experiments. We even sometimes find new species in that cave environment. And we were living in that cave for 6 days. So it was really interesting, incredibly, incredibly beautiful, extraordinary experience. And I was there. That was before I went to space. But some of my crewmates on that mission had already been to space, and they agreed that it was just as extraordinary, almost just as extraordinary as being in space. It was so cool. And I spent a lot of time scuba diving underwater, but I hadn't really done any of that caving experience, and that I had no idea how incredible things were under the surface of the ground as well as they are under the surface of the ocean. So I would really encourage you, if you like to explore, go scuba diving, explore the ocean, go into some of these extraordinary caves underground. There are so many different types of adventure right here on Earth.
All right, I echo that. I've been diving for over a decade, and that's exploring a whole new world that a lot of people don't get to see. So you can do that right here on Earth. And you've had some amazing experiences throughout your training. I can only imagine, a place I'd love to visit one day is the Aquarius reef base. So that must have been a blast, living and working underwater and being an aquanaut as well.
Yeah, absolutely. That's a second kind of analog. Instead of the cave, we have missions where we live underwater as a small crew. And I did that back in 2002, even way before I was an astronaut, when I was working here as a scientist. But such a cool experience. You're living and working underwater, kind of the reverse side of an aquarium.
Very, very cool. Well, Jessica, we have time for a few more questions, but I do want to talk about a little bit of a fun challenge that we can introduce to classrooms and get them doing, because I'd love to see some of the results. So as some classrooms may or may not know, NASA is planning a return to the moon with Artemis. So landing the first woman and next man on the moon by 2024. So there's this really fun activity called What Would You Pack for a Trip to the Moon? So you can only pack a certain number of things. There's a certain number of space. I believe it's 5 inches by 8 inches by 2 inches. So not a lot of volume that you can take to the International Space Station. So as I share a few links with the students, Jessica, I'm wondering if you could share maybe some items that would be in your little pack for the moon.
Oh, that's a good question. If we're thinking just about kind of personal effects, because first of all, I'd want to make sure that I had all the tools and hardware that I needed and a lot of different things to collect scientific examples. That would be foremost on my mind, because we're going there to learn more about the moon, but not only learn more about the moon. Learning about the moon teaches us about our own planet and the formation of Earth and the formation of all the bodies in our solar system, and more about that with regard to the universe. So much to learn by exploring the moon. I think if we're talking about my personal effects, I would probably bring some kind of little hard drive that had things to remind me of home. Pictures, maybe some recordings, voice recordings of my family and friends and loved ones, things to kind of keep you connected and remember all of the things that are really important to you back on Earth. Maybe even some sounds of nature, some good books on there. I think we could utilize space effectively if we kind of put all that stuff together on some kind of memory drive, as long as we have some way to access those files.
All right, very cool. Well, the website's up there on the screen. We'd love to see students taking part in this challenge and then using the hashtag NASA Moon Kit. So you can do that on Facebook, you can do that on Twitter, you can do that on Instagram, and I'm sure, take some pictures of your little kit, what you would bring, and try and be, go to expert mode, use the measurements and kind of fit what you have in the space that you have. And you can even tag Jessica if you want, so she can check out some of those pictures, and you can check out her Instagram and Twitter, where there's some amazing photos as well from her time. So let's take a few more questions because we have a little bit more time. So I'm going to go back to our class in North Bay. Let's bring them in live.
Hi, my name's Peyton, and what was your most satisfying achievement?
My most satisfying achievement, probably those 3 spacewalks. Spacewalks are the riskiest thing that we do as astronauts, because you're essentially out there in your own little mini spacecraft. When you're inside the space station, there are more layers of redundancy if something were to go wrong or you were in some kind of emergency situation. But when you're out there in your own spacesuit, you are just one little mini self-contained spacecraft. And so I think, not only is it the riskiest thing we do, but it's really the most physically and mentally challenging thing that we do. And because of that, it becomes the most rewarding thing that you do, because you're out there on your own with that spectacular view of the planet, which I think it feels even more extreme when you're outside of the vehicle. You're separate from it, just like I was describing. So I would say that is probably the best achievement.
All right. We've talked, a lot about some of the things you were able to do in space, but a lot of questions coming in are about just meeting your basic biological needs, whether it's exercise, whether it's going to the bathroom, and food. Can you tell us a little bit about some of the everyday things you had to do on the space station, how they were a little bit different?
Yeah, you could see some of those in the video that we showed at first. And that's one of the interesting things. When you arrive in space, you're very, very well prepared for all of the technical aspects of the job. So the really complicated procedures and the pieces of hardware, we are really used to that because we've been trained on it so well on the ground. But what you can't prepare for are those everyday things. And so you actually feel like a newborn when you arrive on the space station. You have to learn how to go to the bathroom, how to learn how to eat and drink and just do all those daily life functions, which are really just in the background. You don't even think about, of course, when you're here on the ground. So that takes a little bit of time to adapt to. Using the toilet and understanding, it's like a vacuum. It's running with a vacuum. So it sucks things down. And there are some different techniques to help you make sure that you do that well, and how to fill the water, and just, even just filling up your water packet. And then what can you do with the water? Well, you can have fun with it as well. If you squirt some out, and you could see in that video, you have this big glob. It almost looks like it's a gel, but that's just water, because the surface tension is not being disrupted by gravity and making it fall down and all come apart. It's able to maintain the shape of all of those water molecules sticking together. So all of those things you have to really, kind of adapt to and get used to. But I think that's a great way to think, because these things are really important problems to solve for our future exploration as well. One of the big ones is exercise. You saw the exercise equipment that we have on the space station, and it does an incredible job of maintaining our bone density and muscle mass to bring us back to Earth healthy and safe. However, on these missions back to the moon and eventually onto Mars, we're going to be in a much smaller spacecraft. The Orion spacecraft has only the volume about of a minivan compared to a 5-bedroom house on the space station. So unfortunately, we won't be able to fit those very large and complicated exercise systems like we have on the space station. So right now, NASA engineers are trying to develop and evaluate what kind of exercise system will still be able to keep us healthy, but fit in that much smaller environment. And that's really quite a logistical challenge for the engineers. So if you have any ideas on that, please send them our way.
All right. I'm glad that we covered a little bit about bathroom. It doesn't matter if it's an ocean explorer who's rowing across the ocean or some climbing a mountain. Students want to know, how do we get that done? That's pretty important. So good stuff. I'm glad we covered that a little bit today. Mrs. Foster's class in Alabama, come on in.
Has anything ever gone wrong while you were in space?
Well, there are, of course, a lot of little things that happen that we don't expect during the mission. And so there are things that happen all the time where a piece of hardware breaks. So I would say something that went wrong quite often was what we were just talking about, the toilet breaking. So we had to, do some repairs, and we have regular maintenance that we do on all the systems to try to offset some of those problems. But that's one of the really critical aspects about our job, is that we have to be ready for that. We have to be able to adapt and change and be capable of fixing these things. And luckily for us, we have an amazing team on the ground. So it's not just us up there having to solve all these problems on our own. We rely on all of the experts on the ground whenever something goes wrong, and they guide us in the right direction. They actually even provide us with very, very detailed procedures to make sure that we can repair and replace and get things functioning again. So yes, absolutely, there are small things happening all the time. Things break, things fail, just like they do here on Earth. People make human mistakes as well. The important part is to be resilient and be able to adapt and rise to that challenge and keep on going. And that's something that I think NASA does very, very well.
All right. Let's go to Ms. Mahala's group. I can see we've got someone front and center ready to go.
Given a chance, would you be a full-time astronaut or a full-time aquanaut?
I think I heard that. Was that given the chance, would you be a full-time astronaut or aquanaut?
Yeah.
Okay.
I think the astronaut, because, having been an aquanaut and lived underwater, that was definitely an incredible experience. I would love to do that again. But I think there's something even more special about going to space. And maybe that's just because it's even a little bit more difficult to attain. Fewer people have done it. It takes a little bit more effort to leave the planet than it does to just dive down into the ocean. So I think I'll stick to my astronaut career for now. I'll let you know if that changes.
All right. Good to know. Visiting YouTube, you talked a lot about how amazing it was on the space station, and how, you didn't want to go and that you'd go back in a heartbeat. But there must have been something that wasn't a lot of fun to do, or something that you don't miss from the space station, or something that you had to do regularly.
Yeah, sure. Just like anything else, there are pros and cons to every job. And there are sometimes things that get frustrating with our operations up there. And, I would say that not having any running water would be the one thing that I really appreciate running water down here on Earth, because you stay clean. We have kind of like a sponge bath system that we use to shower, and you feel fine while you're up there, but you do miss that sensation of running water, of just, standing in the shower and feeling it, or jumping into a pool and having water really immerse all around your body. I think that's something that I was happy to return to. And, a normal toilet as well. The space toilet does, you get used to it and it's fine. But, you know, things are always a little bit easier in that regard when you have gravity on your side.
All right, fair enough. Let's go back to your home state. Let's bring our class in Maine back in.
Okay, go ahead and ask your question. Hi, my name is Jay. What do you like best about Maine?
What do I like best about Maine? Oh, wow. So many things. Well, right now, I actually was just there a couple weeks ago. I hadn't even seen my mom since I'd been back on Earth because of all these travel restrictions with COVID. So I went to Maine a few weeks ago to see her, and I saw my favorite season. I saw fall in Maine, and I love all the colors and how vibrant and bright they are, the reds and yellows and orange. And, you know, I'm not sure if you even appreciate that yet because you've grown up in Maine, but the rest of the country doesn't really have that. The fall in Maine and in some other parts in the Midwest are really special because we have all of those deciduous trees and that climate where we have all of that seasonal variation. And I can tell you that living here in Houston, we don't have that. We kind of have two seasons, hot and hotter. And we don't have all those deciduous trees with the changing leaves, and they're not subjected to that thermal cycle as much anyway. So that's one of my favorite things about Maine is seeing the fall foliage. So please enjoy it for me if there's any colorful leaves remaining up there. I think you still have a little bit, maybe on the tail end of it now.
Yeah, I'm a little bit further, well, probably pretty close, maybe a little bit further north here in Canada, and we've lost a lot of our tree coverage. We had a big windstorm, so we're definitely ready for that big winter change here. Whether we like it or not, it's coming. So I'm glad you got to see the leaves because they are absolutely spectacular. Mr. Fisher's class, do you guys have a follow-up?
So you talked a lot about how much you love space and what you want to go home.
Can you get a little closer for us? We're not getting the question.
Okay. So when you were in space, you talked about like how much you loved it and how when it was time to go home, you didn't want to go home. But was there any time when you did want to go home and when you missed Earth?
Yeah, there are certainly times, if there's a big event happening for your friends or family or, a birthday or some kind of special achievement or something that you would celebrate with your loved ones back home. I think those are the times that you think, it's difficult to be away or, even worse, if something bad happens to somebody and you want to be there to help them, whether they're sick or they've had some kind of accident. Those kind of things do make you feel that you are far away and separate from Earth and from your loved ones. And luckily for me, my friends and family were all really healthy and safe. And so I didn't have any of those big moments, but that would certainly be a time when, you might feel that you're missing something by not being back on Earth.
Okay, and I want to bring in Ms. Moore's class one more time, our fifth graders in Newmarket. There you are.
My name is Allison, and I have a question. How do you know where to land, like where the the Space Center is?
So when we come back from space, we actually land in the middle of Kazakhstan, and we don't actually land it like an airplane. We're not like a pilot flying down and finding the runway and navigating to it. That is all automated with the automatic systems on board the spacecraft. And it's all been calculated by the really, really smart orbital mechanics engineers that have figured out where they want us to land so that they can go extract us safely with the helicopters and the ground support teams. So they calculate that. They calculate where we do our deorbit burn. So the magnitude of that burn and the position that you're in when you burn those engines will then dictate the trajectory and where you're going to land on Earth. So the ground teams do that for us, and we actually just have to sit there and passively monitor it to make sure that things are going well. If we have to, we can take over and issue some of these commands to generate that, and then we may or may not land somewhere else if we need to change that. But basically, it's an automated system that puts us back down in the area that they expect us to land, which they know will bring a safe landing for the capsule.
Okay, and let's work in one more question from our YouTube community. You guys have been absolutely incredible. Sorry we can't get to every single question, but I think that's just the nature of an event, a virtual event like this. But we do have a teacher wondering about advice for young women who are maybe tackling challenging math or science courses. Do you have some advice?
I would say the biggest piece of advice is stick to it. If that's what interests you and that foundation that the STEM fields provide, science, technology, engineering, math, really fundamental skill sets that can help you with so much in the future. So I would say stick to it. And I'll give you the other best piece of advice to keep in the back of your mind. It's all worth it. I felt that so many times throughout my career, and especially when I finally made it to space. There are certainly challenges that you'll face along the way. Things will be difficult, but if you stick to it, I promise you it'll be worth it in the end.
All right, awesome. Well, again, a huge shout out to all of our classrooms who tuned in via YouTube across North America. Thank you for the amazing questions. I want to give a huge shout out to our camera classrooms. Thank you for your awesome questions. I want to remind everybody, we'd love, if you took any pictures today, we'd love to see them posted online, and you can tag Exploring by the Seat of Your Pants or EBTSOYP, and then have a think about that Moon Kit Challenge. So there's the website one more time. Take a picture of what you're taking with you and hashtag it NASA Moon Kit, Instagram, Twitter, Facebook. You can share them there. We're hoping to see lots and lots of pictures coming online. And then, of course, follow Jessica at AstroJessica. To check out pictures from her time in space and what she's up to now, because Jessica, as a NASA astronaut, I'm sure there's always things you're doing, new training, new things happening. So
absolutely. I would love to see what you guys put in your moon kits, and I'd love you to follow along with the adventure. Thank you for everything today. Great to see you all.
All right, Jessica, thank you so much for joining us. I'm going to bring all our classrooms into the screen. If you guys want to give a big thank you to Jessica before we sign off. Thank you so much, everybody. Thank you, Jessica. Thank you, NASA. Big shout out to John and Tim who helped organize today as well. Thank you so much, everyone. And we're going to sign off for today.
All right.